So, hello students, myself Sachin and I'm your tutor here and I'm going to teach you mathematics. I'm just mainly going to teach you mathematics, that is mathematics. Okay, so we will just wait. So, we will do mathematics. Okay, so of which class? So, we are just going to do the mathematics of class 11th. So, we will do the first chapter of class 11th, that is sets. Okay, we will learn about the sets, what are they, and what would we learn in the sets. So first of all we will learn about the definition. What is it? And we will understand the definition with the help of some examples. Okay, then we will learn what are the notations of it. Okay, notations, and the third the form the in which the set in which we can just write them, the form in which we can just write them, the form. Okay, so let's go with this chapter. So first of all we will just start with the our definition. So what it want to say, what is the definition and what is it? Okay, so so here it is definition, that is sets, and the definition is just given in as follow, that a set is a well-defined collection of distinct objects called elements. Okay, so what it's saying, what it want to say, it's saying that a set, what is set? A set is a well-defined collection of a distinct objects. Okay, he's saying the words which we have to focus, that are distinct and well-defined. This is the main thing. Okay, that you know very well about the collection. This is something you're just collecting, that you have some pencils, you have some pens, you are just collecting them, that's a collection. Okay, and what is the meaning of this, the main word distinct and the well-defined. Okay, so the set is a well-defined collection of distinct objects called elements. Okay, those objects which we are just taking in a set, that's those are called elements. Okay, first of all, what we will do, we will understand this definition with the help of an example. Okay, so there is a set which is just given here, that is a is equal to, that set would be there's a notation notation. Okay, a set is denoted by capital letters, capital letters. Okay, no issues. And its element represented by small letters. Okay, so like example, set a, anything you can just take, any alphabet you can take, set a, and elements are the elements which are in it are denoted by small letters, that is a, small b and c. I'm just taking three elements, and the elements would be uh, denoted by small letters. I have just taught, I have just tell you, and it will definitely be in curly brackets. Okay, it would definitely be in curly brackets, and the notation of set is always a capital letter. Okay, this is okay. So there is an example which is just given here, that is the set a, which includes 1 2 3 4 5. These are the natural numbers which is from 1 to 5, and it's a these are the distinct element. Distinct means fixed elements. Okay, so these are the distinct objects and they are well defined. They are well defined. How they are well defined? As we know, if you want to define them, so what is the definition of these numbers? That is, these are the natural numbers, and which is from 1 to 5. This is the definition of this set. Okay, so it is a, this set, this is a set, and that's why it is a set. because it is a well defined. Okay, it is a well defined. So we can say that these are the elements when we define when we just saying that it's a well defined. So in that thing we can just say that these are the elements, okay, with the help of definition. Are you getting? Okay, okay, I will just take a contrast example. Okay, so I will just say the set of five numbers, the set of five numbers, like is in B, the set of five numbers. It is a set. I'm just saying it is a set which is a the set of five numbers. Okay, this is a set of five numbers. Okay, okay. What would you say about this set? It is a well defined or not? Is it or not? So it is not. Why? Why? You can just say one person A would say that set B would be 1, 2, 3, 4, 5, and there's another person who's just saying that set B would be 1, minus 1, minus 2, minus 3, minus 4, anything, anything. Okay, and the another person is saying in another way, and another person is saying in another way. So in this way, you can't say anything about this set. You can't say that you are not able to define you are not able to write the elements of this set. You can't say that what are the distinct elements of this. Is a definition. Distinct means fixed elements. This is not fixed. It is not fixed. 1 2 3 4 5 at a time I'm just taking 1 2 3 4 5, and at a time I'm just taking this. So it is not well defined. Okay, it is not a properly defined that what is the set, because we don't know what are the elements of it. So meaning of well defined is if it is well defined, so you are able to write the elements of it. Okay, that's the main thing. Okay, so in the same way, these are the colors. Okay, these are the fixed colors: red, blue, green. Okay, it is a well defined, it is very well defined. Okay, so it is a set. You do you know which set it is? Do you know? It is a set of vowels, and they are well defined because in alphabets the vowels are well defined, means that they are fixed. They are you can just define in a very proper way. So that's why C is a set. It is a set. It is a set. It is a set. But it is not a set. Okay. Okay. I will take another example. Okay. There's another example of which is not a set. Okay. There's another example is C. It is saying the set of most five famous food. Okay. Items. Okay. So some food lovers would say that like is in like there are many food items like is in some like is in paneer sabji, and like is in there are many items, food items like is in burger, and some would say there are five items are according to one person the items are a burger, chili potato, and like is in french fries, and there are five items he has just taken. And another person is just taking the five items are like is in dal, roti, and chawal and salad and these things. So the this set is not well defined because you don't know what are the elements of the set C. So that's why it is not a set. Now you would understand what do you mean by a set. It's a well defined collection of distinct element. It's a collection. It is a collection. It is a kind of collection. You have just collected some elements. Okay, but it is a well defined. Okay, now you understood. So we will go on the next slide. So okay, so now we will learn. Now we will learn what are the forms in which you can just write a set. Okay, okay. So first is our rostered form. So what is it? Roster form. Okay, so what it want to say? Roster. It is a roster form of a set. Of a set. Roster form of a set. Okay, so in this there is nothing required. In this kind of notation, there's one thing that you have to only directly write the elements, okay, in a curly brackets. Like isn't this is a set A. Okay, notation is same in both of the form, but if you talk about like is in roster form, so in this form you have to only use the curly brackets, Okay, you have to only use the curly brackets, and you have to only simply you have to just write the elements of it, like as in 2, 4, okay, 6, 8. Okay, these are the elements of this set. Okay, distinct elements, and they are well defined. So like as in these are the even numbers from 2 to 8. Okay, this is the definition of the set. And what we were saying, that uh, roster form is just mainly in which elements are listed inside a curly braces, means these are the curly braces, and elements are just mainly listed. You have just listed them. So this is a basic form. You can just take in many other examples, like as in b, and you have just taken only curly brackets, and you have to just give the elements, like as in I'm just saying car, bus, and you can just take an aeroplane, not is airplane, auto. These are the set of this element. So you can just take anything, you can just take any object. You can just you have, if you want to just uh, give in the roster form, then you have to only listed the elements of that set only. This is a simple. Okay, now we will talk about set builder form. So what is it? So set builder form, in which there's no any like is in there's nothing that you have to only write the elements. There's nothing like that. Okay, elements are described as in by common property. Okay, so what is it? It is not same as a roster form. Okay, so in this you have to only give the property. That's the what is the quality, and what is the like is in definition. You can just say like is in definition. That's I was saying in it, that A is the set of A. It is the set of, you can just say online also in written form, and it is a set of all, no, it is set of even numbers from 2 to 8. Okay, 2 to 8. Okay, so it is a set of even numbers from 2 to 8. Okay, so it is the same as it. Okay, 2 to 8 means, but it's saying even numbers 2, 4, 6, 8. These are the even numbers, and it is from 2 to 8. So it is the same as A. Okay. So now there's another form also, in which you can also define set builder form. That is, X is an element. You don't know what this is, but it mainly include in A. Okay, these are the elements of A set. So that is denoted by X, and that is, you can just say even numbers. Okay, that is, say X is a, just wait. Okay, X is a even number. Okay, such that such that X is greater equal to and less than equal to 8. Okay, are you getting? So it is just mainly lying between the 2 and 8. You know very well, there's a number line 2 and there's an 8, and you are just saying the elements which are just lying between these two numbers. And there's also property, these are even numbers. So there is also 3 that would not be included because it is not an even number. Okay, are you getting? So this way you can just like isn't denote the set in set builder form. And there is an also roster form, that is easy one. And set builder form is little tricky, and I think is more, but it is, you can just you can just make it bad by practice. Okay, so X is an even natural numbers less than 2. Okay, so if we want to write it in the okay, we can also denote the this as B also. Okay, because it would be same. So it is B. Okay, B. Okay, if you want to write it in a roster form, what are the elements of it? So you can just imagine that X is an even natural number. Okay, even natural. These are the same definition of like this. These are the natural numbers. Okay, these are the natural numbers which are less than 10. Okay, less than 10 means 10 The numbers which are less than 10 is 9, 8, 7. These, if you want to say these are the natural numbers, so they must be greater than 1. And these are the even numbers, so they are 2, 4, 6, 8, those only. Okay, so that is a is only. So this is the same as this. Okay, this is the representation of this. Okay, but we can also write in this way or in this way also. Okay, this is also a rostered form. Okay, oh sorry, set builder form. Okay, and in this way also you can just write. Okay, only you have to just tell about its property. This is also property, this is also property, this is also property. Okay, so set builder form is just mainly about properties. Okay, so now we will go further, and now we will understand about some specific sets. Okay, specific sets means there is some property of them, and this is the one of them. This is empty set, which is also called null set. Okay, so what is the definition of null set and empty set? So it is a definition. There is nothing. Empty means you know very well. If there isn't something empty, and you, I'm just taking an example. Okay, just to take an example. You have a packet of chips, and you're just saying there are chips inside it, and you will say that if you're eating, you know very well it would go empty at some time, after some time. Okay, so after some time there is nothing in it because you have eaten, you will eat all the things, so it would go empty. So in the same way, the set, okay, the set in which there is no element, that set is called empty set. Okay, no issues. So it is also called null set also. Okay, the set having no elements in it, that is called empty set. That would be denoted by, there are two notation of it, that is phi. This is called phi. This you can pronounce as a phi. Okay, and there's an also notation, that is, this is pronounced as a phi. Okay, phi. Okay, so there's another notation. There's a two curly brackets, two curly braces, and there's nothing element, you can say there's nothing. So for empty set, so simply you have to only write those braces. Okay, there is nothing in it, so you have to write in this way. Uh, these both are okay. These two notations are just for empty set. Okay, so you can just take examples. Okay, so he's just saying that month with 32 days. So you know very well there are 12 months, so you have to tell that month which have 32 days. You know very well the months always we have 30 or 31 days. So you know there is nothing, there is no any month which having 32 days, so we can just say that there is nothing in it. Okay, so there is nothing in it. It's an example of empty set. Natural number between the 2 and 3, it is saying, you know very well natural numbers, and it is mainly going to start from 1 and 2, 3, 4, 5, and is going on. What it's saying on number line, that's 0, oh not as 0, 1, 2, and 3. These are the natural numbers. What it's saying, natural numbers between 2 and 3. 2 and 3. Is there any natural number between the 2 and 3? No, nothing is there. So what we will say, that it is also an empty set. Okay. Students aged 200 years. What it's saying? It's saying, is there any student in any class, you in your class also, that who has an age, means who is 200 years old? So would be possible or not, but it is not. From scientists, that there is now person, there is no any person who is 200 years old. It is very impossible thing. You know very well, now the people are not going beyond 100, but it's saying there's a person who is gone, there's a student, sorry, there's a student who is aged of 200 years. How it can be a student? Okay, so there is no any person in it, in the life. It's impossible thing, so it is empty set. So now, quick check, is 0 is an empty set? Okay, just wait, just erase it. Okay, what is saying, this is 0 is an empty set. This what is saying, you can just write as an a. Okay, 0. So could you just comment on this, that if is it empty set? No, it is not an empty set because there isn't something inside it that is zero, and it is a real number. Means like it's a number. It's a whole number. So it's a number. And what is the definition of empty set? The definition is that there's no element inside the braces. Means there is no element in the empty set. So it is not. We can say it is not empty set. Why? There is a reason. It is not empty set because it contain zero in it. इसके अंदर zero है, so that's, oh sorry, it includes mainly zero, so that's why it is not a empty set. Okay, now I think you would understand. I assume you have understood the basic definitions and things. Now we will go the most important thing. Not most important, it is also a very important thing. That is a subset. Okay, we have learned there's a what is subset. Oh sorry, we have learned that there is a set is a collection, well defined collection of distinct objects. Okay, so it is sub means sub, you know very well. There is something upper and there is something lower, that is called sub something sub. Like it's a, if it is an inspector this is a sub inspector. If it is a something bigger, something have more power, so its lower part is sub, which includes sub. So that's why we have set. Okay, so its part, it's lower, it's, okay, it's junior you can say, that is subset. Okay, so okay, what it want to say, we can also understand by some diagrams also. So you can just say A is a set that is 1 2, you can just take any well defined numbers 1 2 3 4. Okay, and what is the next subset? That is B. Okay, so B has 1 2. Okay, so what is the definition of, first we will learn, then we will just see the example. First we will learn what is the definition of subset. So it's a notation of subset A, subset of B, if every element of A is also an element of B. It means that every element of A means it, what it's saying. I have just taken different notation, no issues. You can just say B, this is B and this is A. But because it's just saying this is okay. A is a subset. Now here is A is, and I have just taken B as subset. Now, okay, according to its definition, A is a subset of B. A is a subset of B means B is a set. Okay, are you getting? B is a set, this is set, and A is a subset. That is one. So what is the definition? The definition is very simple. What it's saying, that every element of A, it's saying every means every element. Every element of A, okay, is an element of B. Means every element of A is element of B. This means that anything which is in this brace also in these braces. Okay, are you getting? So A is a subset of B. Okay, that is why, because all the elements which are in A, that's also are in B. That's why A is a subset of B. Okay, I feel if I will say B is a subset of A, would you comment? What it want to say, that every element of B would be in A. Okay, so we can just say, we can just see that 1 and 2 are in B. That every element for being a subset, every element of B should be in A. But here only 1 and 2 are in A. But 3 and 4 are not in A. So B is a not subset of A. Are you getting? Now I think it would be clear in your mind that B is not a subset of A. But A is a subset of B because every element of A is in B. But every element of B not in A. Are you getting? So we can just see the example subset. Not there is no nothing required for seeing this not subset. You only see subset. So A is a subset of B. A, you can say 1 2 is a subset of 1 2 3 or Y. There is an every element of this set is in this set. Yes, 1 is there, 1 is there, 2 is here, and 2 is also there. So here also a is there, a is there, b is there, b is also in the set. So a, this is subset of this. Okay, so not a subset, it's also given. Why? 1 comma 5 is not a subset of 1 2 3 4 5. Okay, 1 2 3 4. So you can think and you can just imagine that you can just say, sorry, not imagine. Okay, 1 comma 5. Okay, these are the elements of this set. Okay, we can go step by step. Okay, there's an element 1 which is in this set and which is also in this set, no issues about it. Okay, so now if you will go for further, for being in a subset. Okay, for being in a subset of this set, 5 should also be there in this set, but it is not there. So that's why 1 comma 5 is not a subset of 1 comma 2 comma 3 comma 4. Okay, that's clear, I think. Okay, if you got any doubt, so you can just say me, and any topic you want further, you can just comment me. Okay, thank you.